You're listening to Economics Detective Radio. My guest today is Caleb Watney of the R Street Institute. Caleb, welcome to Economics Detective Radio.
Hi, Garrett. Thanks for having me on today.
So our topic for today is artificial intelligence, AI algorithms in particular. Let's start by discussing your debate you had in Cato Unbound with Cathy O'Neil. First, let's frame this. Cathy O'Neil wrote a book called Weapons of Math Destruction. That's not me mispronouncing it. It's a pun. And she brought up this worry that algorithms could be used in ways that would have bad outcomes. So how about you start, since she sort of initiated a lot of this debate, how about you start by summarizing who is Cathy O'Neil, what are her concerns, and how did this whole debate get started?
Yeah, no, happy to. To my understanding, Cathy O'Neil is a mathematician. I think she kind of used to work in the financial sector, using a lot of these, big data algorithms to try to predict, various aspects of financial markets, and then kind of grew fed up with a lot of those practices that she felt were disingenuous. And so kind of went into academia and decided to shine a spotlight on some of these practices from there. And so her book is really kind of a synthesis, I think, of a lot of the main concerns about algorithmic decision-making and an incorporation of AI into decision-making that a lot of people have concerns about today. And so, she talks about predatory lending and about hiring decisions being made by algorithms and, a bunch of other sort of examples that she lays out in her books. And I think she's very concerned that there's this view out there that because we're using algorithms and AI in certain decision making, that suddenly it becomes unbiased, and that because algorithms aren't human, because they're just mathematical instruments, that removes all bias from the equation, and now you never have to worry about that again. And I think she's very concerned that we'll basically plaster over a lot of legitimate cases of wrong decisions being made and sort of hidden biases going unexamined just because we're so taken in by these mathematical instruments. And I guess my pushback to that would be certainly it's totally possible for algorithms to be biased. Human programmers can choose the wrong data sets. The data sets can be incomplete. They can be either incompetent or malevolent in their machine learning applications, and that can lead to all sorts of bad results. But that isn't typically what happens. And when it does happen, it's usually the fault of sort of the government procurement process, and that a lot of the positive competitive feedback loops that happen in private markets that give companies incentives to fix problems with their algorithms don't exist in the government sector, and that when we should be worried about algorithms, it tends to be more in these government applications.
Okay, so we're sort of drilling down to the specific cases where algorithms have failed us, where they've sort of started to be used. This has gone from, science fiction to reality just in the past few years. Now we're seeing algorithms used, for instance, to determine how harshly a criminal should be sentenced, which is sort of something you might expect to see in Black Mirror, but we are starting to see in real life. So let's talk about some of the ways. How have these algorithms been used wrongly? Let's talk about some examples.
Sure. I think the criminal justice system is kind of a good case study for some of these complaints. So you have companies that have developed algorithms that can kind of predict the risk that a given defendant will either not show up for trial or will commit crimes in the future, or any number of sort of bad behaviors you may want to predict based on, have they done these things in the past? Kind of what are some of their base demographic factors like age and gender? They typically avoid more sensitive factors like race, but some people have accused them of using proxy variables like what neighborhood you live in, or proxies for socioeconomic status, like how many times have you moved in recent months, and so people are very concerned that algorithms are incorporating all these things that we don't want to have influencing our judicial decision making and that judges are kind of giving these algorithms too much discretion. So a very popular example happened in, I think it was 2016. There was this guy, Eric Loomis, who was sentenced to, I think, 5 years in prison, in part because he was deemed high risk by this private proprietary risk assessment algorithm. He and his lawyers wanted to appeal the decision and be able to examine the algorithm that gave him this high risk rating. But because it was proprietary, they weren't able to. And because sort of the judge and the defendant had the same amount of information, the judge also didn't necessarily know how the insides of the algorithm worked. The Wisconsin Supreme Court said that it wasn't problematic, especially saying, as the judge said, he did not really rely on it. He said it was like, a small factor into his decision making, but it was primarily his discretion that led to this sentence. And so the Wisconsin Supreme Court has put sort of some limits on how these algorithms can be used, but that kind of sparked a whole national conversation around what is the proper use for these algorithms, and should they be in our criminal justice system at all, has been kind of some of the worries.
Yeah. I guess it's comforting that it wasn't just an algorithm with the power to automatically determine someone's sentence, but a human judge who simply was able to reference the algorithm. But if it had said something absurd, like putting a petty thief in prison for 100 years or putting a serial killer in prison for 3 months, then at least there was some human oversight and someone who could use just common sense and maybe not blindly follow what the algorithm says if it breaks or if it's calibrated wrong. But a lot of these decisions that algorithms are making are the kind of things where we defer to the algorithm. For instance, high frequency trading. You can't have a human second guess what an algorithm's doing if it's doing it 1,000 times a second, because humans simply don't move that fast. So I think a big part of our worry with algorithms is that we'll turn over discretion to them, and then maybe we'll find out that something in the black box, we didn't set our objective quite right, and that objective won't be, and the algorithm, in ruthlessly pursuing what we told it to, will not ruthlessly pursue what we meant to tell it to do.
For sure. And kind of, building off of some of those concerns, going back to the criminal justice example, there was a ProPublica study that came out around the same time as the Loomis decision that claimed to have taken some of the output data from the algorithm, the Compass algorithm that was used in the Loomis case, and said that basically it had found a discrepancy in the false positive rate for African Americans and for white Americans. It claimed that sort of this algorithm was racist, and that's of course the big concern that bias could be seeping in, and because the algorithm is proprietary, it's difficult to examine and know for sure how it's operating. Now, recently, there's been a lot of pushback to that study saying, no, actually, it doesn't seem like that was the case. Or if it were the case, it might be kind of a mathematical sort of inevitability, just given sort of base differences in the population rate. And that sort of gets into a deeper, more fundamental question about what are sort of the differences, the different definitions that you can have for algorithmic fairness. Compass, which was the algorithm in question, the company said that they were basically optimizing towards a definition of fairness where a 6 on their 1 to 10 risk scale meant the same thing for an African American and for a white American. It seems, as far as we can tell, that it is true. But then if one base demographic has a higher recidivism rate on average, then it's just mathematically inevitable that they will also then have a higher false positive rate, because you're just kind of changing the denominator in that ratio. And so there's a lot of really complex statistical discussions that are sort of happening here beneath the surface, but a lot of the media conversation has been focused around these questions of bias and accusations of racism.
Yeah, well, one issue here, and one issue we have to worry about with algorithms in general, is that they only know what we tell them. And, one might worry that the American criminal justice system has maybe racism built into it, or police or prosecutors have some latent racism, and then they're more likely to investigate African American suspects, and so then African American people would register as having a higher recidivism rate, when actually, they might not, or they might just be overstated because they're more likely to be investigated. And then this algorithm would pick that up and simply, repeat the, multiply the same bias. So it's taking the human bias as an input, and then just creating more bias, although it itself is not, obviously cannot have any sort of racial prejudice.
Yeah. And I think that's kind of where you start to get into the case for optimism in some ways about the application of these algorithms. Is yes, there is the concern that bias from different parts of the criminal justice system could seep in. If you are disproportionately policing and then arresting people from African American communities, that's going to maybe distort the statistics that the algorithm is using. But one of the key things that algorithms do is that they force us to make a lot of our implicit assumptions explicit. So, when a judge is weighing a particular case and trying to decide whether or not to grant them parole or whether or not to deny them bail or what to set their bail at, there's a whole host of sort of implicit assumptions that judge is making about kind of their history and their background. And we have there's a vast empirical literature kind of showing all the ways in which humans and human judges are biased in a wide variety of ways. But an algorithm forces us to make a lot of those assumptions explicit, which then, if those assumptions can then be viewed by other people, can be challenged. And that's in some ways kind of like the story of human knowledge, is the way that we transfer knowledge to other people. We make our implicit assumptions explicit, have them challenged by other people, and then hopefully have better assumptions. And so I think in the criminal justice system, we've started to see that there are ways that we can grow, that we can have more efficient decision making when we have this partnership of algorithm and judges. And so I think sort of the best example for this is currently happening in New Jersey. New Jersey completely got rid of their cash bail system and is now relying on a risk assessment algorithm that the judge will consult when they're making their decision about whether or not to deny a particular defendant bail. And that reform happened in January, started right at the beginning of 2017. And over the course of 2017, they saw a 20% decline in their jail population with no increase in their crime rate, which has been pretty exciting and kind of indicates that there may be gains to be had from making more accurate predictions about what's actually the likelihood a given defendant, either skipping town before their trial or committing crime before their trial. And if you can make more accurate predictions about those, you can let a lot of the low risk, defendants stay in their community, spend time with their family, not lose their job while they're waiting for their trial.
Yeah, that's really interesting. And I think that I would be really worried about an algorithm that was telling us to give many fewer people bail, but if it's telling us to be nicer to give more people bail, then I'm a lot less worried about it. In this case, the humans, it seems, were overcautious. And this is one of those times where the outcome definitely seems like a positive. I should say also that people who get bail are much better able to put up a solid legal defense if they decide to go to trial and rather than plea bargaining. It's actually really hard to meet with your lawyer and gather paperwork and evidence and things like that if you're stuck in jail. And so I can definitely see this as a positive for just making the system more fair, giving people a fair shot to defend themselves. But so we've been talking about the legal system, and your essay, in response to Kathy O'Neill, points out that many of our concerns about algorithms are with algorithms being used by the government. But Kathy O'Neill talks about, and her background is with algorithms being used in the private sector. So why do you think there's this? Why should we be concerned with the public versus private use of algorithms? Why should we think of those differently?
I think it depends a lot on sort of like the feedback loops and whether or not you're punished for making inaccurate decisions. If you're, a totally private corporation and you're trying to use an algorithm to predict something, and maybe you're going to use that information to try to produce more value for your client. If you are making an inaccurate prediction, especially when compared to your competitors, they'll presumably have a better product, be able to provide more value for their consumers, and you'll kind of get slowly driven from the market unless you're able to find whatever the error in your algorithm is and then fix it. But in a lot of these sort of either explicitly government domains or partnerships between government and private sector, you do not have that same kind of feedback loop or any sort of competitive forces that would incentivize or force the operators of the algorithm to make sure that they're using them correctly. For example, one of the examples that Cathy O'Neil cites in her book has been, some of the interesting applications of algorithms in the education system to try to rate teacher performance. And this is a situation where it is, a public school district, but oftentimes contracting with private developers to then develop and implement these algorithms. But again, because it's the public sector and there's no kind of competitive check or force there, they do not have the same feedback loops, the same incentives to make sure that the algorithms they're buying are actually what they've been told they are. And so we've suggested, and by we I mean sort of R Street, the think tank that I work at, is the government procurement process, which sounds really boring, but is basically the process by which government decides to buy new algorithms or new anything really, could use an overhaul. And we can use that process to make sure that there are more checks when the government is trying to buy new tools. And I think this is very different from what it sometimes gets called, which is regulation. I don't think this is really regulation. If Google decides internally that, we want to make sure before we buy something from an outside contractor or vendor that we want it to satisfy a criteria A, B, and C, no one would say that Google is then imposing regulations on the rest of the market. If the government is just dictating the terms by which they're going to buy an algorithm from a private vendor, that's a totally different story. And so we think that the government does need more checks before it's buying algorithms to make sure that they're being developed in open and transparent manners, that, you have the right kind of privacy checks, and that ultimately the algorithms are doing what they've been sold they are doing.
This sort of harkens back to a debate that goes back at least a century, maybe a few centuries, about the difference between markets and government and central planning versus decentralization. There is this, when you have profit maximizing firms, they do have this objective measure of how well they're doing. And when I say objective, I don't mean it perfectly reflects everything we'd like to see in the world, but $10 a profit is objectively more than 9 and less than 11. And that's really something that's great for algorithms. An algorithm that has some kind of really clear goal can really, that's where they really shine. They can iterate many times and they can really maximize that goal. Governments, when they generally don't price many of their services and the things they provide. You can't really put a dollar value on Law and Order or a park that you don't charge entry for. A lot of these things they're we're trying to fulfill some kind of vague social good goal, which and saying it's vague doesn't mean it's not valid. But yeah, that it comes back to almost the calculation problem that people like Hayek were talking about a century ago, or just a little less than a century. But
and I think it's helpful to sometimes think about this, with a tangible example. So if you take Tinder, for instance, Tinder uses lots of really advanced machine learning algorithms to try to match people together with people that they might be interested in. Based on their previous swipes, based on what sort of information they have in their bio, based on where they live. If Tinder just consistently does a bad job matching people together, there's a whole host of alternatives that people can and are, choosing between. And so ultimately the algorithm that gives people the kinds of matches that they want is much more likely to be the app that ultimately wins out. But, in the criminal justice system, the defendant doesn't get a choice of, which court they would like to be tried in based on whether or not they think the algorithms are fair. They don't really get any say in that. And so there's way more opportunities for both incompetence and malevolence to strip in. I would tend to think that oftentimes when there are mistakes in the applications of algorithms, it tends to be more on the incompetence side of things. But Yeah, having that sort of competitive pressure to force you to really double check your assumptions and make sure that your data sets are accurate and that you're not biasing your data in some particular way it's really important.
Yeah. So where does that lead us if we're really concerned that our algorithm may be biased? Should we say put a constraint on it? Like if we're really worried that our existing criminal justice system is biased against African Americans, you could tell the algorithm you must have an answer. You must give sentencing numbers that have the same average for black and white defendants. You could constrain it to that and say, okay, maximize within this constraint. That would be one way of approaching it. Well, first, what would would that be an appealing way to do it? And what other potential ways could we constrain, or what other ways could we constrain these algorithms, or make them less likely to be biased in bad ways?
So I think there's a whole number of technical solutions that you can really dive into the weeds on, and you can advocate for optimizing towards one particular definition of algorithmic fairness, versus another. And for your listeners, I can send you a paper that you can include in the show notes that basically talks about a lot of the different types of algorithmic fairness definitions and why some of them are inherently incompatible with each other. And it's an interesting read if you'd like to dive more into the different technical solutions that people are considering for this. My concern, more on the policy side is how do we create an environment where, regardless of what the best technical solution is at any particular time, like I think it's likely to change, as algorithms get more complex, as we get better data, as our methods of machine learning advance, we want some flexibility to sort of allow our algorithms to evolve over time. But we want to create sort of institutional constraints that make sure that regardless of kind of what the state of the art science is right now, that they're being applied in responsible ways. And we sort of take an approach here that transparency is really the best way that you can do that. Ultimately, you run all sorts of problems when these algorithms are all proprietary and defendants can't examine them. That's really kind of a violation of some fundamental matters of due process. In our criminal justice system, we want defendants to be able to challenge the assumptions that they are being convicted under, and also for there to be a public explanation of why they were sentenced in the way that they were. And so if we want judges to be able to check their own biases by relying on algorithms, we need those algorithmic assumptions and the data sets that underlie them to be public to some extent. So we've suggested kind of open sourcing the whole algorithmic criminal justice system. And that basically in the procurement contracts, when governments are working with private companies to build these algorithms, that they buy rather than rent these algorithms. And so be willing to pay more upfront, but then transfer all ownership of the algorithm and of the underlying data sets to the government officials. And then they can make them public. And then when they contract with future people, they can build off of those existing algorithms in a public fashion. And then you can have, stakeholders from both the right and the left, from ProPublica and the ACLU to Right on Crime in our street, examining these algorithms, making sure that there's not, different types of subtle biases. And also when you make them all sort of open and transparent, it also handles some of the other concerns about, the black box of machine learning. Because even if you don't understand the specifics of how the algorithm is making this decision, so long as the underlying data sets and the methods of machine learning being used are all sort of open and available, you can have other people replicate the process again and again to make sure that, sort of the inputs and the outputs are reliable and that you're not having bias inserted at any part of that equation. And we have some proposals that we're kind of working on right now to sort of flesh out that idea. But the general idea of making the government have all of these algorithms be open and allowing other people to critique them, it also lowers the bar of sort of technical competence that judges have to have when they're evaluating this. If there's already been 10 different research papers analyzing the effect of this algorithm, that's going to be much easier for a judge to then make a decision about whether or not a particular algorithm is a valid resource, rather than them trying to figure it out all by themselves.
That's really interesting. So you would make these algorithms public source, and then people, researchers, people just on the internet in their spare time could then, if they wanted to, test them out. For instance, punch in a hypothetical, maybe one or 1,000 hypothetical sentencing cases and see what the pattern is. And if there are weird discrepancies or problems, then it could immediately be on the front page of Reddit or something. Hey, or in the Huffington Post, or just in the public eye. So that provides a lot of feedback.
Absolutely. And there are dedicated organizations that have lots of resources. Civil society cares a lot about the application of justice in America. And, you're seeing more and more, people who have training and experience in AI and machine learning who are interested in some of these questions that are now working at think tanks and other, analysis organizations that I think would love to be able to do this kind of research and analysis for us. We also think it would be useful to kind of set up maybe an innovation prize system so that you can kind of open yourself up for suggestions from anyone. So if you're a private developer and, you're playing around with these algorithms and the data sets that underlie them, and you can see, hey, you guys are using this specific data set. Here's this form of bias I found in it. And now I've been able to strip the data set of its bias. And here's the increased efficiency that you get from the algorithm. They should be able to be rewarded for that. And so, whether or not the Department of Justice has sort of almost like a bug bounty program, I think there's a number of ways you could set that up. But just making sure that private developers in their spare time, if they can find problems with this, can be compensated for disclosing those problems. I think that's another way for us to get towards better algorithms in the long term while still making the whole process open to the public.
Yeah, there's something called Kaggle competitions that they're just these online machine learning sort of competitions where someone will post a data set and people compete to make the most efficient algorithm to predict some kind of outcome from a sample that the original poster withholds. And so there's already there's some good mechanisms, some good communities for public checking of algorithms. So using those mechanisms could definitely help if those algorithms are going to be used in important ways by governments, by bureaucracies, by the legal system and the courts. So we've talked a lot about the legal system. Determining bail and sentencing. Are there other algorithms, other uses of algorithms that are of concern?
So certainly the criminal justice system is where I've spent most of my time. I know that, there are other researchers that have tried to point out potentially problematic situations in lots of other applications and have, different solutions for there. And I think that kind of gets to a broader point that, the applications of AI are going to be very broad and varied, and the solutions for making sure that they're used responsibly are also going to be very broad and varied. We can't just have sort of a one size fits all solution for all possible applications of algorithms in our society. Because again, I think that most of the applications in the private sector tend to have been working really well. I mean, Google is using really advanced algorithms to create self-driving cars, and those have the potential of saving tens of thousands of lives a year on our roads. All sorts of cool applications in drones and having drone delivery systems that Amazon is experimenting with. There's tons of really cool applications, and we want to make sure that we don't slow down the development or the deployment some of these really awesome, interesting algorithmic systems in the private sector. But there are reasons to have more concern in the public sector where there's not as many checks. And we think that the sort of open source model can work well for the criminal justice system. It may work less well in other government agencies. For instance, some people have experimented with using algorithms to try to detect tax fraud. And you probably wouldn't want those to be open source because then people could kind of game the system. You could, check your filings beforehand, see if they ring the alarm on the algorithm. And if not, you can keep on tweaking it until you can get past the algorithm. And so there are some reasons, for secrecy and making sure people aren't able to game the system for keeping some algorithms private. But the criminal justice system, that's not nearly as much a concern. And so we think that sort of transparency and open source seems to be the best solution in that situation.
Yeah, you could imagine someone, they'd have to be so tech savvy to do this, but you could imagine someone who is maybe a career criminal. They're with the mafia or something, doing a bunch of things to make themselves appear like they have a low likelihood of being repeat offender. So, for instance, if it took into account neighborhood where you live, they make sure they go and live in a particular neighborhood that the algorithm is going to read as low likelihood of committing crimes or something like that. But but a lot of the things they'd have to do would actually involve doing not committing crimes, not having prior offenses. So I mean, we're very happy for people that's not even gaming the system. That's just doing exactly what the system wants you to do.
Exactly. And if you look at sort of which of these variables tend to be the most predictive, it really is kind of the past indicates a lot about the future. And so, people with histories of violent crime are much more likely to commit violent crime in the future, just kind of as a base analysis. And so if people are trying to game the system, they're going to find that, hey, the best way to get past this is just to not commit crimes. And if that's what they're doing, then that's great. But I think it's also worth reflecting on, sort of going back again to this sort of like larger theme of, algorithmic bias versus human bias. And in a lot of situations, humans have all sorts of implicit hidden biases that aren't being examined and can be through algorithms. For example, we know that once you reach a certain age, your likelihood of recidivism drops down dramatically. But that doesn't tend to be accurately reflected in the conviction and parole decisions that our criminal justice system is making now. But has been reflected in certain policy simulations that people have done with algorithms. And so I think there's so many margins for improvement that we're only just now beginning to discover when we can bring better data science and statistics to the mix.
Yeah, so you briefly mentioned algorithms used for self-driving cars, which I know you've written about elsewhere. That's sort of, there's this thing libertarians like to talk, or classical liberals like to talk about, which is that private power, the private sector, it has a very different type of power than the public sector, because the private sector can't use violence against you. The worst they can do to you is deny you some kind of quid pro quo. So a company that you apply to, the worst thing they can do to you is not give you the job. Or, I mean, it's not literally the worst thing, but that's sort of close to, it's a fuzzy lower bound on how bad things can be. But the government can put you in jail for the rest of your natural life, which is a very bad outcome. And so maybe a much greater worry for the potential bad things governments could do versus the potential bad things a private corporation could do. But what we all like to talk about with the self-driving car thing is essentially the trolley problem, a case where your car is in a situation where it has to either hit a bus full of school children or drive you, the passenger, off a cliff. So that's a case where the private company or indirectly through its algorithm that sold you your car is making a life and death decision, and people are very worried about that. Should they be?
I think it's worth some caution, but broadly, I would not be too concerned about it. Again, I think it goes back a lot to what are the fundamental incentives that these companies or these actors are facing. And I think if you were to talk to Elon Musk, if you were to talk to the people developing Google's driverless cars, they would all tell you that their absolute worst fear, their worst nightmare, is that you have a single mom driving in her driverless car over a bridge and then falls off a cliff because it gets hacked or there's a problem with the system, the algorithms aren't working correctly. That would absolutely destroy their business. You would get headlines for months about why these aren't safe. Consumers would move away from them in droves, and there would be real consequences for private actors who kind of undertake really dangerous decision making. And consumers are kind of already skeptical of driverless cars. And you've seen that companies are responding in turn. So, Waymo, which is Google's driverless car division, for instance, has undertaken tons of steps to make sure that, it's nearly impossible for their cars to be hacked. I mean, within reason. I think they've done pretty much everything they can. Their cars only connect to the internet when they're safely stored off of the highway, not when they're driving. They have, several backup systems in place if their primary system fails or shuts down for some reason, they have a secondary computer system that can safely take the car to the side of the road. But again, the ultimate standard here is not one of perfection. I think, unfortunately, people sometimes like to hold, computers and algorithms to a standard of perfection. But the relevant standard is what's happening right now, what's happening with humans. And in the case of cars, we had 37,000 fatalities on the road in 2016. Which was higher than 2015, which in turn was higher than 2014. For the first time in decades, we were seeing actually an uptick in the number of yearly fatalities for cars on the roads. And that's due to, cheaper gas prices as people are driving more, but also because people are getting distracted and looking at their phones and texting more. And so algorithms and cars, they don't have to be perfect. They just have to be better than the relevant alternative, which is humans. And I think that takes place both in driverless cars, but also in the criminal justice system. We can't expect algorithms to be perfect. They're going to make some mistakes, and those mistakes are going to be tragic. But if they make fewer mistakes, and if they can learn from their mistakes in a more systematic and robust way than humans can, we can achieve a much better future.
Yeah, human drivers, a human driving a car is just, taking an ape brain and putting it in control of an immensely powerful, fast machine flying down the highway at 130 kilometers an hour. It's amazing that we have as few accidents as we do, but anything that reduces that number, even if it's not perfect, is an improvement.
For sure. And, we've already seen that, 94% of accidents on the road right now, according to the National Highway Traffic Safety Administration, are due to human error. I think we think of lots of factors, like environmental conditions and, a log falling down and hitting a car in the middle of the forest or, crazy circumstances like that. But the vast majority of accidents are just caused by human error. Robots don't get distracted. They don't get drowsy. They don't have blind spots. And so, it seems like, in theory, at least, they should be able to eliminate the vast majority of accidents. And we've seen in practice, as these companies have been deploying driverless cars on the roads, the number of miles they've driven versus, there's only been one fatality so far, and that was with a semi-autonomous car, the Tesla, I think back in 2015. That's been the only fatality so far. And the vast majority of the crashes that you're seeing, even with testing cars today, are, other cars bumping into the driverless car. There was a big headline just a couple months ago where, they were launching driverless cars. I think it was in Las Vegas, and there was a truck that backed into it. And the headlines say, accident, collision for driverless cars on the first day of their deployment. But of course, it wasn't their fault. So yeah, there's going to be tons of sort of translation issues of how we try to communicate to humans. That, these robots and these humans these robots and these algorithms are getting better. But, they're not going to be perfect initially.
Right. There was a recent accident that it was non-fatal, but a Tesla hit the back of a fire truck. And I was reading about that, and it's basically the Tesla semi-autonomous driving depends on radar, and it's really good at responding to things that are moving. But if you're following a car and that car changes lanes and there's a stopped car ahead of it, because the stopped car isn't moving and because the radar has never seen it move, it'll just sort of assume it's part of the background and may not be able to react to it. So that's one area where I mean, there's a reason these cars are still semi-autonomous. One issue, of course, is the transition between human drivers and autonomous cars, is that human drivers trust a semi-autonomous system too much. You have people, even though their system is only meant to to stop, to prevent them from getting in an accident, from rear-ending someone, and maybe it can, help you with lane changes a little bit. People will just completely put their total trust in them and be on their phone, be not paying attention, go to the back seat to grab something or something. So it kind of seems like getting over this hump from getting from entirely human drivers to entirely autonomous cars has some danger in the middle.
Yeah, there's certainly been a lot of speculation about that, and I think there's certainly something there. So when people talk about levels of autonomy within driverless cars, they usually use the standards. There's the Society of Automotive Engineers, SAE. They have a taxonomy of, I think it's 0 through 5. in autonomy. And, level 4 and level 5 are basically completely autonomous. They don't need any human interaction. Level 1, started adding some, automatic braking. Level 2 is like sort of semi-autonomous. It can drive by itself on the highway. And level 3 is that awkward zone in the middle where the cars can mostly drive themselves, but they still need occasional human input. And yeah, you've seen companies like Google who run experiments on their private test courses at these various levels and found that humans do. Once they've seen that the car can handle most situations, they start to trust it almost too much. You can run into some problems there, which is why you've seen companies like Google and Cruise and a few other ones they're kind of trying to skip this level 3 area because they've seen that there's so many difficulties associated with that handoff of human control to autonomous control. And so they're just really focusing on trying to get level 4, level 5 autonomous vehicles developed and tested as quickly as possible so that you can just entirely skip that. And I think this is part of what's missing from the discussion is that they're developing way faster than most people are expecting. In fact, they're on the roads right now today in the Phoenix area. Waymo has fully autonomous level 4 cars driving around the roads with no one in the front seat. For the first several months of their deployment there, they had a safety driver there who's kind of making sure nothing was going wrong. But then they felt confident enough in their creations that they've taken the safety driver out of the front seat. There's still a stop button you can press in the back, but the car is completely driving itself.
Yeah, I've been in several online debates where people who know a lot more about the technology than me say, this is as recently as last year. Oh, it's 30 years away. There's this problem. They can't deal with this problem. And it's sort of this outside view versus inside view where I say technology seems to go very quickly. Things go from prototype to adoption, in usually a couple years. I don't know anything about the engineering problems, but I know that I wake up every day and engineers have solved more of the world's problems. And so I think the outside view that technology marches along and is coming quicker than we expect seems to be winning in this case. I keep saying that my 2003 Honda CR-V has to last till self-driving cars because I don't want to buy a new car in the intermediate.
No, that's totally right. I live in DC and I have never owned a car and would like to never own a car. In the city center, it's easy enough to get along without a car, but I'm trying to hold out on moving anywhere else, until at least driverless cars have developed more. And yeah, kind of on that inside-outside view, I think that's totally right. And people will, oftentimes point to, troubles that autonomous cars still have. They still struggle in, heavy rain and in windier conditions, and when the lines on the road are not as clearly painted. But, they're getting better at those all the time. And I think that's actually one of the reasons why Google chose sort of the Phoenix area as an initial deployment spot was because it has, very clear infrastructure. It doesn't struggle from a lot of rain. It doesn't get super cold. And that's kind of like the key difference between level 4 and level 5 autonomy is like level 4 is able to deploy within a particular area. And then level 5 is it's able to deploy anywhere. And I think we'll probably stay at level 4 for quite a while. But sort of in the same way that there was the slow deployment of Uber from city to city to, metropolitan area, I would guess we'll see a similar thing with driverless cars where especially through sort of transportation network companies like Lyft and Uber, eventually we'll just start adding on driverless cars into that mix as well and sort of, move it from city to city.
So this is all really exciting. It's exciting to see the world change in a big way. The last episode, I mentioned that I expect driverless cars to be a big shock to the labor market, especially in an economy where so many people drive for a living, trucks, taxis, industrial vehicles. If the cars can drive themselves, that's a lot of people potentially out of work, especially if they do it better than a human. We're getting towards the end of our time. What closing thoughts should a listener take away about algorithms, about anything we've talked about what should their worries be? What should their hopes and dreams about the future of algorithms?
Yeah. I think there's a couple of few sort of overarching themes, I think, between, these two conversations. One of them would be always remember the relevant standard. We're not shooting for perfection here. And perfection is likely impossible on some margin. But if we can get better than the existing very flawed humans that both drive and issue judicial decisions, we can have much better outcomes. Maybe sort of takeaway number 2 would be that these sort of implementations of algorithms frequently don't look like replacement, especially not at first. So, with the truck driving example, there's still so many aspects that driverless cars are having a lot of trouble with, driving first mile, last mile through, mountainous terrain in rain. And ultimately, a driverless car can't manage the logistics of what's happening inside the truck with all the cargo, at least not for now. And so experts seem to think that it's still going to be quite a while where, maybe you have a partnership, an autonomous truck that drives on the highway with a trucker that helps manage logistics and, take over in difficult situations. And that would be, a fruitful partnership that actually leads to higher productivity and higher wages for the truck driver. Similarly, in the criminal justice system, we're not advocating, and I don't think we're anywhere near a situation where we'd want to replace judges. It's all about sort of giving judges better tools and more tools so that they can make more accurate predictions when they're trying to make these very difficult decisions. And ultimately, there's some aspects, especially when you get into sentencing. We've been focusing mainly on sort of pretrial and parole, but in sentencing in particular, there's trade-offs between fundamental moral values that we as a justice system are trying to get towards. And it's sort of a weighing of the evidence that seems to be very difficult, near impossible for algorithms to do, at least for the foreseeable future. So takeaway number 2 would be that especially in the near term, I think this looks a lot more like a partnership of AI and humans than it does like AI replacing humans. I think those are the 2 main takeaways.
So you're saying it's more like, it's less like the movie Terminator and more like the movie Her.
Yeah, I think Her actually... It's a great movie. If anyone has not seen it, they absolutely should. But I think that paints a much more realistic portrait of kind of what the future looks like than Terminator does, certainly.
Yeah, and on that positive note, my guest today has been Caleb Watney. Caleb, thanks for being part of Economics Detective Radio.
Thank you.
The discussion question for this week is, what is your greatest concern with the use of algorithms? Where do you see them potentially being misused? And if you want to answer that question, you have to go to Economics Detective on Facebook. That's the Facebook group called Economics Detective, and request to join. I'm trying to get all my listeners in one place so that I can communicate with you. If you have a Facebook page, you may have noticed that in the last little while they stopped showing them to people. They made it so unless you pay Facebook for ads, they just don't show your page to people. But groups have not been axed by the algorithm, and that's why you may have noticed many creators and people like me sending their audiences to groups instead of pages. Just another case of algorithms having interesting effects on the way we live our lives. In this case, social media algorithms, which we didn't talk about a lot this episode. If you want to talk about social media algorithms, go ahead and do it in the comments of that Facebook post. I'll be back next week, and thank you for listening.